Hey, the 6-Bolt Von Dooms Lab. This is a quick release for Hook of the Reaper version 1.3.4E. So why am I doing another quick release? It seems like I'm doing a quick release every other day. So hopefully this is the last quick release for a while. So I just wanted to get these out before I get more into the RPG Brooks board and do a whole bunch of changes. Because if I have a whole bunch of changes, then if I have to change something, it's a lot harder to kind of go back to rip that stuff out, then put the change in, then redo things. So that's why I was like, well, I just want to get these changes in before I to start getting really knee deep into the RPG Brooks board. As you probably see from my last update, I got the colors working and uploaded, so now I can finally make a lot of headway into it. So I got most all the hurdles taken care of, so which is great. So now I just need to code it all out and get it in, so you can actually see the finish line. But so what are the changes that I did? Well, the first one is I added a space variable to the command file. So usually light guns for the first light guns, I mean the first like 10 or 12 light guns, none of them had spaces in the commands. The first one was arcade, which used a space in the serial port command, and we found out we can just use a tab instead of space because I rip out all the kind of spaces because you actually put a command space, then you put another command, so I kind of split everything together from the spaces and I rip out all the spaces. But once you need a space in there, it kind of doesn't work. Then actually I was working with the Pico gun and they're using spaces too, so that's kind of the second light gun kind of manufacturer, kind of both two smaller ones that are using spaces. So I thought it's probably a time to add in a space variable. So now I put in percentage underscore percentage. So this represents a space. So now you can put the command this, then whatever the rest of the command is. So that kind of makes it a little easier. So usually in MameHooker was percentage s percentage for the kind of the data or the output signal. So it just kind of uses the same format as percentage underscore, which kind of looks like a space percentage. And if you put that in, it just gets converted to a space. So that's the easy thing to do. The next one is, I kind of noticed this a while ago, is for the Ultimarc commands, I had the follower. So this is just following. So if you had an output signal, and if it went on from 0, it was off. Then if it went like 1 or higher, it went on. But there is other signals. Usually there's like red, green, and blue signals that are 8-bit values, so 0 to 255. Kind of just like, the strips, the RGB strips. You have 8-bit red, 8-bit green, 8-bit blue. And kind of some of the examples, I took this from Jurassic Park, right? You have lamp seat red, lamp seat green, and lamp seat blue output signals. And each of those output an 8-bit value for those red and green blue values. So I kind of wanted to get that into Hook of the Reaper before I get totally into the RPG Brooks board. So which is good. So now you can actually follow these RGB value output signals. So it was pretty quick. I put it in, but I kind of, well, here I'll show you how to put it in first before I show you some of the problems. So here is actually Ultimarc command. So you come down here, you can see here follower RGB value. You have value color and value group. So If you come down to follower, now you have follower RGB value. So the value color is, red, green, or blue. And it's case insensitive. You can put in, capital R, ED, or all capitalized. Doesn't matter, as long as it's just red, green, or blue, so it knows which one. Then value group is kind of when you have a group, right? You have three of the signals. So you have red, green, and blue. Those three will all be in kind of like one group. So that's kind of the info on how to do it here. I'll show you an example of it, which I use. So here's group 1 is the four RGB lights I have on the top. Group 2 is the bottom 4 RGB lights. So as you can see here, I have lamp seep R. So I did controller 0, which is the Ultimarc, then 1, which is the 4 top RGB. So then I did follower RGB value, then I put red. Then, it's good to start at 0. So 0 for that one. So then I went on to green, and it's kind of the same thing. You go, pretty much the only thing that changes, right? You go from red to green, right? Then you have the fourth one, lamp seep blue, right? So you just go blue, and that's the last one in the group. So when you start another group, it's going to be 1. So as I come down here, this is just one color. I think it's red. So the dino eyes. So that's what I came in here and put it as red. And like I said, it's, next group, right? So I did these 3. So on the next one, I put 1 in. So then you put red in because I think the dino eyes were red. So this is on group 2, which is the bottom 4 RGB. So that's kind of how you put them in. You have to put 4 of them in, which kind of a little pain, but you're right. So it's like these are the 3, right? You have this one, the red, green, and blue, right? But that's how you put it in. But what was kind of the major problem or the drawback that I saw? Well, the problem with it, with Ultimarc, to write an intensity for one pin, it takes 8 milliseconds. So if you need to write all 3 RGB pins, right, because that's 8 milliseconds for like one pin, which is red, green, or blue. So since there are 3 of them, it's going to take 24 milliseconds, right, which is kind of bad, right, because it starts adding up. So if you look at this example, actually, right, so you have, so this is 4 here. So I have 4 green, 4 blue, and 4 red, right? So that's 12 right there. Then coming down here, I just did 4 with red. So that's 4. So 12 plus 4 is going to be total of 16 pins, right? So total of 16 pins is going to take 128 milliseconds to write it. So that's a lot of time. So what was happening, since these come, the red, green, and blue come in fast, they all come in at the same time. So once you get red, it takes 8 milliseconds. Well, you get red, green, and blue, then I think it was 16 milliseconds later, you get red, green, and blue again. So I get the red, green, and blue. So then it takes 24 milliseconds just to write that, but the next one comes in 16. So there's 8 milliseconds difference. So it kept on adding 8 milliseconds to it, and it had this huge buffer. So only after playing for like a minute or 2, I turned the game off, and it still was doing data to the pin, to the RGB lights for like a minute or 2 until it finally stopped. And that's just because, like I said, it takes every 16 milliseconds it was getting RGB data, but it took 24 milliseconds to write it. So that was for one pin. As you can see, I was doing 12 pins. So what's 12 pins? So 12 times 8. So that was going to be 96 milliseconds. So if I was doing four top pins, it would take 96 milliseconds to update all the RGB pins, where it took 16 milliseconds to get the next value. So you can see that's a huge problem. That's why I had tons of buffering, right? There's minus 16 off of this. Yeah, it's gonna have 80 milliseconds left over for every turn. So that's why I had this huge buffering problem. So that wasn't going to work. So I was like, okay, so I need to delay it. So what I did is, okay, I figured out, okay, it's going to take 128 milliseconds. Then I want 120 milliseconds times 1.5. Well, why 1.5? Well, you do have other stuff going on. If you have, yeah, just these pins, then it'll be okay. But if you had like other stuff happening for like recoil or damage or something else, it would have no time to run because it needs to take its milliseconds to write the pins, right? So that's why I did 1.5 times. So from this case, it's going to do every 192 milliseconds, it's going to refresh both top and bottom displays, which of course is going to take 128 milliseconds, right? So then what's left over, like I said, so you have what, 192 minus 128. So you have 64 milliseconds for the other stuff. And hopefully if that goes over 64 milliseconds, you're still going to have the same problem. So I might have to increase that kind of buffer. But what if you only used one pin, right? So instead of using 4 RGB lights, what if you used one RGB light and so one RGB light. So you take that, so that's going to be 3 times 8 is 24. Then 24 times 1.5 is 36, right? So kind of each pin is like red, like pin, like one red is going to be like 12 milliseconds because it's 8 times 1.5 is 12. So you can kind of figure out from that. It's like 12 milliseconds per one pin. But that's kind of why it came to problems. So it did take like about 15 minutes to actually put this command in, but after I ran it, I ran into this whole problem. But since I knew how to do like refresh displays because I did displays and all that, it didn't take too long to put in a refresh delay into it and also update it. So it works pretty good. It's okay. It still kind of sucks with the Ultimarc. The good thing is when we get the RPG Brooks board, it can write all the RGB pins for all the players in 1 millisecond, right? So that's a huge difference, right? Because in this case, we're using 8 and it's 192, but that's when I'm using the bottom 4 with just one color, red. I'm not using green or blue on it, remember? So the top one I'm using red, green, and blue, then the bottom's just red. If you took like the Ultimarc IO kind of one where it has 96 RGB pins, right, which comes down to 32 RGB pins, right? Because 96 divided by 3 is 32. To write all those pins, those 96 pins, it would take 768 milliseconds. So 3/4 of the seconds just to write all those pins if you wanted to. 32 RGB pins, which is 96 pins total. So that's a lot of time, which can't happen. So that's 32, but the Brooks RGB board is going to have, what, 60 to 80 RGB pins and it's going to take 1 millisecond to write it, right? So that's almost easily double the RGB pins, right? 32 to like 60 to 80, and you're going from 768 milliseconds to 1 millisecond. So it's going to be a huge leap in timing and all that, which is nice. So once I get to the RGB Brooks board, a lot of this stuff will be taken care of, and I don't have to worry about it because it'd be so much more faster. So that's a good thing, at least. But that's why I kind of wanted to get it in before I did the RPG Brooks, this command. And maybe when I get done with the RPG Brooks and the Linux conversion, maybe I'll add it to lead hook strip. But though that was kind of like the major one before I wanted to get to the RPG Brooks, and this just came in at a good time just to get it in. Then the other thing is I updated the non-default lg.hor and the custom usb.hor command files. These are for light guns that are not in Hook of the Reaper. So one is for serial port and the other one is for USB HID. This is when you add in your own light gun that's not in, like you have the Reaper or the MX24 or Blamcom. If you don't have any of those, you have like a custom one. This is how you enter it. Then you got to fill out the non-default lg.hor or the custom usb.hor. So those are kind of outdated, so I updated them too. But that's it. So that's the release of E. So hopefully this is the last quick release of E. Then hopefully in Hook of the Reaper version 1.3.5, I'll have the RPG Brooks board. So with all the new stuff in it, so which would be cool. But that's it, and all the files are up on the website. Thanks. Bye.